Let's see where you might have been in a pre-calculus course and where you might need to go and what you might need to understand to have a broader perspective on what you have learned in a pre-calculus course. Pre-calculus is kind of a branch, a transition from high school level mathematics to college level mathematics. Mathematics at a little higher level of abstraction. Pre-calculus can serve as a transition to calculus, which is, of course, a gateway to continuing education in the mathematical sciences. It also serves as a foundation for a lot of direct real-world applications that don't rely on calculus, that are important for a lot of other courses that don't really build on pre-calculus but use what you know in pre-calculus. So calculus takes you on. Other courses use what you have and expand your understanding of pre-calculus level topics. And most of the curricula, most of the applications of pre-calculus are modeling applications, modeling things that happen in the real world. Okay, now pre-calculus consists of what? I'm going to classify it this way. You got analytic geometry, which starts with something as simple as the equation of a straight line or the distance between 2 points in the plane, and moves on through the conic sections. Okay, we have matrices which arise naturally in the solution of systems of linear equations. This leads us to matrix algebra, which leads on to linear algebra and higher forms of algebra, deeper forms of algebra that relate to what we know, what we can learn about functions. Okay, so then we have the elementary functions, which is really the most pervasive core of the study in pre-calculus. And it's something people come out of pre-calculus without really any picture of what elementary functions are or what the elementary functions are, and it's essential to know this. So elementary functions, we have the algebraic properties of those functions. We have their geometric properties, often related to the graphs of the functions. We have real-world applications of the elementary functions and combinations of elementary functions. Okay, we learn to construct graphs of transformed and combined functions. Okay, so we transform functions by vertical shifts and vertical stretches and horizontal shifts and horizontal compressions, reflections, rotations, etc. And then we can combine these functions by adding them, subtracting them, multiplying them, dividing them, doing composites of functions. We need to be able to construct graphs of the functions that we get when we do this. Of course, that can get really complicated when you have complicated combinations of the functions. We don't want to perform miracles here, but we want to get an idea of how to construct graphs and not punch them into a calculator and look at the pretty picture, which doesn't really tell you much of anything. Although the ability to interpret a graph is still important, you need to know how to construct them. And this leads us to the idea of functions and function families as entities in themselves, which is a fairly abstract concept, fairly abstract idea, not all that difficult to get a hold of if you do it right, but very important to understand this sort of thing if you're moving into calculus and into higher mathematics. It's a foundational for later courses, and also very important for just pre-calculus based modeling. Okay, so what else do we learn in pre-calculus? Now there are other topics. The elementary functions, I could list them. You have constant functions, you have power functions, you have exponential, logarithmic functions, you have the trigonometric functions, sine, cosine, tangent, the inverse functions, and so forth. Okay, these are all elementary functions and their combinations, and I detail that in a subsequent video. Okay, so what else do we learn? Well, we learn to formulate problems in a slightly more powerful way than what you probably learn in most high school mathematics courses. You learn a little bit more about the foundations of mathematics, and especially about doing elementary proofs. The ability to prove things is the ability to really deeply understand them. And the better you are at deeply understanding things, easier and more powerful calculus is going to be, etc., etc. You learn to solve new types of equations. Okay, well, we learned to solve what? Logarithmic equations, trigonometric equations, exponential equations, as well as polynomial equations, rational function equations, etc. We learned to manipulate expressions and equations to take a mathematical expression or equation and put it into a form that best serves our purpose. And that means, of course, rearranging expressions to achieve purpose. We have trigonometry, which kind of stands by itself in addition to being part of what we can do with elementary functions. Trigonometric functions are among our elementary functions, but in addition to that, triangle trigonometry, whether you think of it in terms of functions or not, is extremely powerful in modeling the real world, especially in engineering and physics and a lot of other areas. Vectors are essential for understanding higher mathematics. When you get into the third semester calculus and beyond, a lot of what you look at is done in terms of vectors. So vectors is another application of trigonometry, closely related to matrices and matrix algebra, because when you get into linear algebra is a study of vector spaces. Okay. And of course you have your trigonometric identities, which are important in their own right and which support all the other aspects of trigonometry, trigonometric functions through these applications. So the context, we have foundation for modeling in courses that don't go beyond the level of precalculus, and for the transition to calculus, where we try to make calculus as easy and powerful as possible, where we study rate of change, slope, difference quotient, rate of change being the keystone concept of calculus, and sequences of series, which come you really get into sequences and series late in the first year calculus sequence, and they become extraordinarily powerful as you move into the higher mathematics. And they're also important for modeling just at the precalculus level.